Hi and Assalamualaikum. So for this presentation slide, which will present about sport skill analysis of rugby, which is ball passing. So this is our group member, which is Darwish Adam, Akimullah, Fikri Adam, Haikal, Edri Nasrun, Aiman, and Isfitri. Table of content. First we go through introduction, procedure and objective. Second, anatomical basis of human body, which is bone involvement, muscle involvement, joint involvement, and lever system. Number 3, we go through mechanical basis of human body, which is law of Newton, form of motion, displacement, acceleration, and velocity. Number 4 is step of maximizing skill and performance. And lastly, we go through conclusion. So for introduction, passing is fundamental skill in the game of rugby. Learning the basic skill like passing in rugby can enhance the athlete performance. This passing skill was to describe the biomechanical determinants of passing velocity in group of highly proficient players. So the objective of this passing is to analyze the biomechanicals and technique, to evaluate the accuracy, speed and consistency, and lastly to identify strengths and areas for improvement. Next is recording procedure. First, prepare the equipment. Second, choose the movement to analyze. Third, set the camera perpendicular 90 degrees to the sagittal plane of motion. Next is record multiple trial and angle. Next, ensure the good lighting. We record this at location at Padang UiTM Seremban. And lastly, put the marker on the used joint.
So Assalamualaikum, my name is Muhammad Isfitri bin Ismail. I will talk about bone involvement in hand. So as you can see at here, we have a humerus at the upper arm bone and radius and ulnar. Forearm bones, carpals and metacarpals at the wrist and palm bones, and the phalange at the finger bones. Okay, we go to the next slide. Okay guys, so for the next slide is the bones involvement in leg. So with a femur at the thigh bone, and second one is patella at the kneecap, and tibia and fibula at the lower leg bones, tarsus and metatarsus at the ankle and foot bones. For the last one is phalange at the two bones. Okay, thank you. Okay, next, this is muscle involvement in hand, which is we have a flexor carpilulinaris and radialis, which this can help in wrist movement and gripping. So for the second, we have a brachioradialis, which is help in bending the elbow, and deltoid control shoulder movement, and bicep help in bending the arms, and then the triceps, which can help in strengthening the arm. Okay, next, this is the muscle movement in the leg, which is we have a gluteus maximus, which is it can help with hip movement and standing up, and the second is the gastrocnemius, which is the calf muscle, important for walking and running, and then the third one is quadriceps, help in strengthening the knee, and bicep femoris, part of the hamstring, which helps to bend the knee, and retinaculum, which it can hold tendons in place around the ankle.
In rugby passing skills, we have 3 joints that it involves to do these skills. First one is ball and socket, which is located at our shoulder. The second one is joints, located at our middle arm. And the third one is condyloid joints, which is located at our wrist. In rugby passing skills, we have 3 joints that it involves to do these skills. First one is ball and socket, which is located at our shoulder. The second one, his joints located at our middle arm. And the third one is condyloid joints, which is located at our wrist.
In this rugby passing skill, we use third class level of lever system, which is the fulcrum is elbow joint, the effort muscle, which is we using our bicep and triceps, and the load is rugby ball, and the function is to accurate our arm and wrist movement when passing. The advantage is increased speed and control during passing.
An object at rest stay at rest. Second, an object in motion continues in motion at the same speed and direction, which is constant velocity. Second, unless an external force like a kick, push, friction or gravity acts on it. So, for the key concept is inertia. Labeled in red at the bottom left. Second, inertia is the tendency of an object to resist a change in its motion. Furthermore, the more mass an object has, the more inertia it has harder to move or stop. So for the acceleration, when a player applies force through muscle movement, it causes the ball mass to accelerate. For example, the faster and stronger the movement, the greater the acceleration of the ball. Second, starting from rest and then increasing speed, acceleration. Third, the image shows the moment the player exerts force on the ball to pass it. In simple terms, a ball won't move fast on its own. Second one is the more force you apply using your body, the faster it goes. This is why a strong pass sends the ball farther than a gentle one. Newton's third law states that for every action, there is an equal and opposite reaction. For example, when the player throws the ball upward, they apply force to the ball action, and at the same time, the ball applies an equal force back to their hand reaction. This law helps explain how movement and balance work together during sport activities. Form of motion, it has three, which is linear, angular and general motions. For linear motion, in rugby passing, the ball moves in a straight line from the player's hand to the teammate, covering the shortest distance between the 2 points. For the angular motions, the player's arms and shoulder rotate around their joints to generate the force and direction needed to accurately pass the rugby ball. For the last, general motions. During a rugby pass, the player's body moves forward while the arm simultaneously rotates, combining both linear and angular motion to deliver the ball effectively.
So, we start about angular displacement. Definition: angular displacement refers to the change in angle as a body segment rotates around a joint. Application: rugby passing. During a rugby pass, angular displacement occurs at the shoulder, elbow and wrist joint. For example, the upper arm rotates at the shoulder joint from an initial angle to a final angle during the ball release. So, this is angular displacement example. You can watch. So, this is our angular displacement in hand position. Start angle 135.8 degrees. At angle 162.5 degrees. Our angular displacement is 26.7 degrees. Linear displacement. Definition: linear displacement is a measure in a straight line from position 1 to position 2, or from initial to final position. Application in rugby passing. Linear displacement in rugby passing refer to a straight line, distance the ball travels from the passer to the receiver. That is all from me.
Hi, my name is Muhammad Haikal bin Abdul Rahim and I will present about movement performance criteria and calculation. Okay, for the phase 1, preparation phase. The player position himself with feet shoulder width apart, knees slightly bent and core engaged. Both hands hold the ball firmly while maintaining the body stability. This phase prepare the body for an efficient and accurate pass. Okay, for the phase 2 is initiating phase. As the passing motion begins, the shoulder extend backward while the trunk rotates slightly. Muscles like posterior deltoid and oblique are activated to store energy through angular motion before releasing the ball. So for the phase 3 is execution phase. The elbow extend and the wrist flick forward as the ball is released. Concentric concentration of the tricep and pectoralis major generate force. This create both angular and linear velocity, allowing the ball to travel accurately towards the target. Okay, for the last phase is follow through pass. After the ball is released, the arm continue moving forward and the trunk leans slightly. Eccentric control by the muscle helps slow down the motion, maintains balance and improving passing accuracy while preventing injury. Okay, for this slide, I will explain the calculation process as demonstrated in the previous video slide. We can see have a three concept of calculation, which is velocity, force, and acceleration. Okay, first, I will explain about the force calculation. The formula for the force is mass multiplied with acceleration. From the video, we get the data which is mass is 60 kg and acceleration is 3.63 meter per second. So, we multiply the mass by the accelerations which is 60 kg multiplied with 3.63 meter per second. So, we get Newton is 239.58 Newton. For the explanations, this means if an object have a mass of 60 kg and acceleration at 3.63 meter per second square, the force applied is 239.58 Newton. Okay, so next, I will explain about the velocity. The formula for velocity is displacement divide time. From the previous video, the data I get is displacement 2.50 meters and times is 0.83 seconds. So, we divide displacement by the time, which is 2.50 meters divide 0.83 seconds. So we get the answer 3.1 meter per second. This means the object travel 2.5 meter in 0.83 seconds. So its velocity is 3.1 meter per second. Okay, so for the last calculation is accelerations. The formula for acceleration is velocity divide time. We use a same video which is same with force and velocity. We get a data which is velocity is 3.1 meter per second and time 0.83 seconds. So we divide velocity by time. which is 3.1 meter per second divide 0.83 seconds. So we get the answer 3.63 meter per second square. This tells us that object acceleration is 3.63 meter per second square when it reaches a velocity of 3.1 meter per second in 0.83 seconds. The conclusion for this slide is all these calculations are connected. First, we use mass and acceleration to find the force. Then, we use displacement and time to find velocity. Finally, we use velocity and time to calculate accelerations. These concepts are fundamental in biomechanics and help us understand how objects move and how force affect their motions.
Okay, so for my side is step for maximizing skill performance. So the first one is prioritize sleep and recovery. So you must get enough sleep to help you to fast recover. So the second one is structure, strength or coordinationing training. The third one is do a follow through on passing. Or the fourth is use proper shoes for reduce sleeping. So protect our leg also. So the last one is optimize nutrition and hydration. So take a good food for our body. So for a conclusion, athlete performance in rugby depends on a combination of strength, speed, skill, endurance and teamwork. To perform at a high level, player must develop physical fitness, technical ability and tactical awareness. Regular training, proper nutrition and mental focus are essential to improve performance and reduce them for injury risk. So that's all from me. Thank you.